Hello. In this video, I'm going to talk about the relationship between a calculation of areas and the calculation of integrals. Integrals and areas are quite closely related, and we're going to explore that relationship here. Consider the integral of f of x between a and b dx. So this is just a general sort of integral. And we can interpret this as an area, and we do it in a very simple way by saying that the integral between a and b of f of x dx is equal to the area under the graph of y equals f of x from x equals a to x equals b. So between these two x values, a and b, if we want to calculate the area under this graph, we do it by calculating this definite integral, which we know is some number. Now, in this particular definition, this word under is rather important, and we're going to have to make this simple version more complicated once we begin to understand what is involved in this word under here, under the graph. But we can begin with a very simple example. Suppose we look at the integral between 0 and pi of sine of x dx. So sine of x is this red curve. Pi is the value here where sine of x crosses the x-axis. We're going to integrate this function from 0 to pi. Our formula says that the value of that integral will be the value of the area which is under the graph of sine of x. What we mean by that here is under the graph and above the x-axis. So that little arch of area right there is going to be given to us by the integral from 0 to pi of sine of x dx. So if we just evaluate the integral from 0 to pi of sine of x dx, the antiderivative of sine x is minus cos. We evaluate minus cos at pi and 0, subtract the values, we get minus cos pi minus minus, which is plus cos 0, and the cosine of pi is minus 1. I've put the cosine function up here in the dotted blue line, and at pi cosine is minus 1, so we end up with the value 2. So the area covered by this first arch of the sine function is equal to 2. So this shows how that particular integral is interpretable by an area. If we were to take the integral from 0 to 2 pi, though, we would discover that the same antiderivative evaluated at 2 pi and 0 gives us 0 plus 0, which is 0. So this particular definite integral is 0, and so it isn't the area of anything here. But what's going on is that as we go through the x value pi, the sine function dips below the x-axis. So this area is not below the curve, it's actually above the curve. And so we have to make our statement about the relationship between areas and integrals slightly better to capture what's going on there. So a better version is that the integral between a and b of f of x dx is equal to the sum of the area that's above the x-axis and below the curve of y equals f of x minus the area which is below the x-axis and above the curve of f of x. So the integral in our particular case here will be a1 minus a2 plus a3. So if we start with the integral and want to interpret that integral as areas, this is what we have to do. We have to add the areas above the axis and subtract the areas below the axis, and that gives us the value of that integral. Usually this isn't how we formulate the problem. We don't usually say we've got an integral, we want to interpret it as an area. What we're usually doing is starting with an area, and we want an integral that will evaluate that area. So here's an example. Suppose we want to calculate the area which is under the graph of y equals 1 over x and between the points x equals 2 and x equals 8. First step is sketch the graph. It's easy to do that now with technology. Your computer, your smartphone can do this for you. And if you are doing this on an exam and they won't allow you to use those technological aids, then you're going to have to use some of your other techniques for working out what the graph looks like. But 1 over x is easy to remember. It's just a curve that looks like this. And it goes between 2 and 8. That's what where the area we want. It's just this area underneath this curve. So to do this calculation, we calculate the area as the integral between 2 and 8 of 1 over x dx. Integral, the antiderivative of 1 over x is log x. We evaluate log x at 8 and 2. So we get log 8 minus log 2, and that is approximately equal to 1.39. So this is approximately what the area is that is below the curve 1 over x, above the x-axis between x equals 2 and x equals 8. In the next video, I'm going to talk about the more general situation where we have intersecting curves and we want the area that is bounded by those curves.